Welcome to the Web Platform Podcast, a developer discussion that dives deep into all things web. We discuss topics relevant to developing for the modern web and the web platform of today, tomorrow, and beyond. Welcome to the Web Platform Podcast. This is episode number 15. Today we are joined with Adam Solove. Adam Solove is head of engineering at Pagemodo. He spent 10 years building web interfaces with various technologies, CGI, Flash, dynamic HTML, just to name a few. So jQuery, JavaScript, MVCs, and more recently, he's been working a lot with functional programming. That's why we have him on the show today. He'll be talking with us about ClojureScript, ClojureScript specifically with OM, which is on top of that. It's React bindings, and React.js, of course, as well as Elm, which is a very interesting compiled to JavaScript language. Our hosts today are myself, Eric Isaacson, UX engineer at 3Pillar Global, Christian Smith, open source developer and startup enthusiast, and Nick Niemeyer, a New Relic JavaScript agent engineer. So welcome, Adam.
Thank you very much.
Hey, Adam, can you give us a little bit about yourself, how you got into the position you're in now, and what led you to the functional programming?
Sure. Well, I followed the very traditional career path of getting a master's degree in classical Chinese literature, and that was a lot of fun. I highly recommend it, actually, if you're planning to become a programmer. That's definitely the right route to go. And so one day I was actually sitting in the library working on some research that I was digitizing and making a little visualization with the map and all sorts of fun annotations, and I realized, boy, actually, building this visualization is a hell of a lot more fun than reading the old books that are the things I'm putting in here. And so that was a kind of, probably somebody would pay me to do that, whereas it's increasingly difficult to find people who are willing to pay you to just be a professor and write things. And so that was sort of the beginning of what eventually became my career in programming. So that was about maybe 10 years ago, maybe a little less than that, maybe 8 years ago. And so essentially I had worked my way through college and grad school doing programming, and it had never occurred to me that programming was like a job or like a career that you could do full time, because I kind of was a very informal programmer. I knew how to set up a server and get PHP and MySQL running and do kind of terrible things. And it never occurred to me that that would be a full-time job, because I didn't do it in a way that really deserves to be a full-time job. And so I had just done programming as the way that I was, whatever else I was doing, right, researching Chinese literature or whatever else I was doing, being able to use computers was my kind of plus one at all times, right? I can always do something impressive in any field by making a web page about it. So since then, actually, I was very lucky to get my first full-time job on the basis of some of those demos that I had done, and that was at a small nonprofit that did Rails work. And since then, essentially, I've just gotten some combination of lucky and through hard work to get to work on a lot of fun projects and eventually get to lead projects, and now actually get to lead teams of people working on lots of projects, all focused on the area of basically building user interfaces. With back in the days of DHTML and then Rails, and Rails generated JavaScript, which is a terrible thing. And now, using more functional paradigms like React and ClojureScript. So that's where we are today.
I see you worked with Flash as well for a little while.
Yeah, boy, we all have our sins to atone for.
So Flash as a technology was actually going to be the end-all be-all for animations and game development, before Unity, before all the days of HTML5. So it's a pretty interesting technology.
Yeah, and I mean, as a technology, it had issues as a technology even early on, even now that we dislike it for more political reasons. It was, in many ways, a painful place to program. But yeah, that's all in the distant past, at least for me.
Yeah, I hear you. So you come from a really extensive background. Flash had ActionScript 3, which turned into a very object-oriented set of methods and classes. And then you had JavaScript. You have all these different object-oriented ways of thinking and developing applications. What actually led you to decide to do functional style programming, and what made you prefer it?
Yeah, that's a great question. For me, building UIs is something that's very different from maybe, what you would learn in a mainstream computer science program, right? In which algorithms are written in in a certain style, and some algorithms are nice to write in an object-oriented style, or some systems are nice to model in an object-oriented style. And so I became interested in, well, what are the actual ways that people who research this, people who are academics, think about modeling user interfaces? And I became interested in that because as I was building more and more complex user interfaces, it was clear that whatever concepts I was using, whatever mental model I had of it, was insufficient to the complexity and the amount of, the size of the state space of even what we would think of as fairly simple UIs. And so if you think about it, problems like, well, I made a widget and it worked. I put it on a page with another widget and they both worked. Except if you use the first one 3 times and then the second one 2 times and then you press forward and you press back, now the first widget stops working. You go, oh, well, okay, well that's because I bound some event handlers in the wrong order. And just the amount of stuff, the amount of state that has to be aligned correctly on a web page for the UI to work is really, really astonishing. So I went looking for what's an actual model that we can take this and comprehend what's going on when we're building a user interface. And that led me to the world of a set of research around functional reactive programming, and then, fortuitously, a kind of revolution that's going on now with writing user interfaces in a more functional style based around maybe 2 main communities. One is the reactive extensions community, and one is the React.js community.
Yeah, it seems like Microsoft has a bigger hold on the reactive community from what I can see.
It's interesting because the reactive extensions started in C# and then in F#, and were kind of part of a set of features for .NET. That's how it started, and that's not where it's going to stop. I mean, the implementation of RX and the number of people using RxJS or RxJava, who are not Microsoft shops, they don't want the Microsoft stack. What they want is the power that this set of primitives of streams with back pressure and reactive. It's incredible. And there's a couple talks by, I think Netflix was one of the key early users of both RxJava and RxJS. And I think a lot of people who have in their mind, oh, this is just a Microsoft thing, are going to be late to the party and miss on some powerful tools.
Definitely.
Adam, can you tell us a little more about functional reactive programming? Like, I'm looking at this, I'm kind of assuming that the idea is that there's so much boilerplate or repetitive stuff about these events that it's better to actually generate that code. Is that what functional reactive is doing? Is it giving you a declarative way to kind of generate all these events and the handlers and the state management?
Yeah, I think that's one way to think about it. It might be helpful to back up and think about it on a more abstract level. Normally when we think about modeling a user interface where things have to change over time, we reify, we make concrete the objects that we initialize a group of objects, some controllers, some models, some views, and then they send around messages back and forth to change each other's state or to form each other. And then, of course, when we need to debug or add a feature, we have to kind of track down what is the actual flow of information through these different objects. And it's often very confusing. And so functional reactive programming at a high level is a way of essentially switching what we consider what we reify. So instead of having permanent objects and data flows between them, we actually write out code about the flows of data and how steps in those flows propagate. And then, essentially, we can just follow more clearly in the code what is causing something over here to change. So, for example, a spreadsheet is kind of close to a mental model of functional reactive programming, right? You have some inputs over here. You have different formulas that take in different inputs and spit out an output. And if you change an input on one side, it might flow through a whole bunch of formulas and a whole bunch of cells and eventually give you output on the other side. And it's easy to trace down, how did we get here from where we started.
So it's a lot to take in all at once.
It's not something to expect. It's not like if you know JavaScript and I'm going to learn a new JavaScript library, right? Oh, I'll just sit down and do a tutorial, and a day later I'll understand what I'm doing. It's something you have to kind of sit down and absorb and commit to. Well, I'm going to read these 3 papers, and I know I have to do it 30 minutes at a time, and then stop and reflect and come back to it tomorrow. A long time. So
obviously, JavaScript is pretty fast. A lot of people consider it to not be a language They don't feel that it's something that should be considered as a full-fledged language. And a lot of the stuff that's being put into the newer versions of JavaScript is trying to alleviate a lot of that pain that traditional back-end developers feel. And I don't think that JavaScript is the big issue that people really have. It's the DOM. And React has approached this a little differently, where they've said, well, we want to have a virtual DOM, piece everything together into our virtual DOM, do all of the changes we need to do a diff, and merge everything together at the very last second. So that's pretty fast. But what we don't see is that the browser engines can handle a lot more now. So the more modern browsers, if you don't have to support the old ones, obviously, they're more optimized to do stuff like, objects that are being watched. So you have mutation observers and things like that. So I guess the question would be, in the future, when we have a more consistent landscape with that sort of optimization, do you feel that the virtual DOM will be unnecessary and React will have been just sort of a stepping stone?
Certainly the DOM technology and implementations have gotten much better, right? Both faster and more complete and more standards compliant. But I think the problem is more that fundamental model, right? We're going to build a UI in XML, XHTML, or HTML, this XML-like syntax. And the only kinds of information it knows about are strings. I actually saw a really interesting comment on Lambda the Ultimate from a long time ago, I think like 2004 or 2005, where Peter Van Roy, who's an academic, was commenting on how HTML is this great system for describing interfaces because it's declarative. But the only problem is you can't actually pass around real data. The only thing you can have in attributes are strings and numbers. Wouldn't it be great if we had to declaratively build user interfaces with something like a tree node structure like in the DOM, but the attributes could be real pieces of data, right? Like hashes or objects or whatever. And that was really, really true. And then as I thought about it, I realized, boy, that's actually what React is. It's this layer where you have a declarative description of what your UI should be that's pretty close to HTML, right? Because you have these components that have attributes. And the only difference from HTML is that you don't have to just talk in strings. You can actually pass functions around. You can pass data structures around.
So I agree that there are sort of two main communities for functional UIs. It's the FRP folks and the React approach. Is there any value to combining those two technologies? Is anyone using those together?
Yeah, and I think maybe we can be real concrete about the fact that they're not exactly alternatives, right? React is an implementation strategy or an engine so that given some description of the DOM that proceeds from a purely functional generation, right? It just generates this purely functional, side effect-free description of the DOM. We can efficiently update the real DOM to match that. And so then on top of that, in terms of how you decide what the state of the DOM should be and how you decide what you want to render, you have some choices. So React puts on top of the virtual DOM a stateful, object-oriented set of system for building components. And other folks will do other things. So you have Ohm, which is a ClojureScript library built on top of React, which provides a way to build components that is generally less stateful, that works well with Clojure's immutable data structures. And then you have other people who are using the power of the virtual DOM in other ways, like Elm, for example. So Elm is a compiles to JavaScript language. It's on the surface very similar to Haskell. And it now has a new set of tools for building HTML components that is based on a virtual DOM strategy like React. But the way that you actually build up the UI, the description of the UI, and the way that you track the state is done in a manner more like FRP, where you have signals that change over time that then generate DOM nodes, which change over time. And so, yeah, I think there's a lot of exploration right now about what is the best way to get the power of functions and the power of immutable data, and then just use this virtual DOM as an engine to get good performance.
Yeah, a lot of the way that I use React today, you still have that mutable junk Like you can corral it all in one spot, but there's still a lot of problems of when exactly does this state update, and how do you make this state instantaneous versus the set state in React, which is asynchronous and takes time, and corralling that all could use another layer.
Yeah, and there's a couple different approaches, even just in plain JavaScript, right? So there's a couple of, for example, cursor libraries that will let you, use immutable JavaScript data, and then your components can just kind of update the little pieces of that data that they need to know about. And it kind of looks from a code perspective like they're just, setting their own state, but in reality, they're really ultimately calling a function up on the parent level immutable data, which gets you all the benefits of a kind of purely functional approach.
Nice. So one big question, you talk about Elm and ClojureScript. So do you think a compile to JavaScript language is the best way to take advantage of these strategies?
Well, I think it really depends on what you're doing. I think there's a lot that somebody who only knows JavaScript, doesn't want to read research papers, just wants to get work done today, can do by understanding React, maybe considering using an immutable data library because that makes things like undo redo easier and it makes some performance stuff faster, and just continue going about their jobs as if nothing else had happened. ClojureScript and Elm, I think, do provide some distinct benefits. It's going to take, you have to have a team of people who are willing to go through and learn it. The ramp-up period for a new team member is going to be higher if you first have to say, well, first learn Haskell, and then go read the Elm docs so you learn which parts of Elm aren't quite like Haskell, and then sit and meditate on the meaning of functional reactive programming for a few days, and now you can begin to appreciate the code base. But I think we're dragging people, we're kind of dragging people closer there. The Elm repo, the Elm GitHub page has a link to a really good version of the to-do MVC project written in Elm that is both faster than pretty much other implementation because you can just see all the state transitions in one place. And I think, as people get pulled into the React community and then kind of start looking even further and saying, boy, these React people have something interesting, maybe I should look at what's even further in this direction. Yeah, I hope we do pull some people who maybe only know JavaScript and get them to learn Clojure, get them to learn some Haskell.
So Elm takes this Haskell-like syntaxed language and pieces everything together in this virtual DOM, similar to how React does. They claim to have even faster results because of their strategy, and they convert to HTML and CSS as well. It's pretty interesting to see that the different types of compile to JS languages are evolving into separate communities. For instance, you have Dart, you have CoffeeScript, you have TypeScript, you have all of these different versions of languages that convert to JavaScript. So what do you feel the difference is as far as these different communities? What do you think? Do you think that the problems that they solve are the same, or do you think that there's something different about them?
Yeah, I think there are definitely several separate communities. I think there's one community that started with CoffeeScript that is essentially, we really like JavaScript and we'd like it to be a little bit prettier and maybe support a few extra features. And so there's a number of CoffeeScript derivatives that also have support for nicer syntax for asynchronous stuff or more of those kind of surface level changes. But they still compile to completely human-readable JavaScript. The people who work in them were pretty much happy with JavaScript. There's a second community that I think is centered on better objects in JavaScript. And so I think Dart is a good example of this, of, boy, the prototypical inheritance and the weird syntax around objects in JavaScript is unfortunate. What if we made a nicer object-oriented language that we could maybe make faster and certainly make prettier and easier to use, less surprising, that compiled to JavaScript? And then I think that's kind of separate from the third and more radical community, which is actually where you would find ClojureScript and Elm. And there's a number of other, like PureScript and Roy, and a number of other projects that are essentially trying to take this more purely functional approach, and often are trying to take a pre-existing language, right, like Clojure or Haskell or OCaml or something, and compile it to JavaScript. And often the generated JavaScript is not as pretty, And the people who use these languages were less happy with JavaScript in the first place. They wanted something radically different and more functional. And then those kind of fall into the camps of the more Lispy kind of things, which don't have types, but maybe have macros or emphasize kind of short code. And then the typed camp, right? People who want to actually compile their code, check all the types, feel sure that the program is more likely to run as a result of that.
I am kind of digging around as we're talking in the repo on GitHub, and I noticed actually that the Elm compiler is written in Haskell.
Oh, yeah.
That made me smile. It's pretty cool. Just like we're talking about all these big picture concepts, but at the most basic level, do I understand correctly that what this is actually doing is generating not only JavaScript, but also HTML, and it looks like Markdown as well, or rendering Markdown?
Yeah, so Elm started out, the creator of Elm, Evan Splitsky, had this original idea, which is essentially, I hate building things on the web. I'm completely putting words in his mouth, but this is what I get when I look at what he did, which is I hate to write CSS, I hate to write HTML, I hate to write JavaScript. I want a language that I can just say, put this thing next to this thing, on top of this thing, beside this thing, and each of them should change as appropriate and affect each other as appropriate. And I don't write the CSS for that layout. And so the initial, for a while, Elm actually was a way you wrote you'd write your program, and it would compile down to both the HTML and the CSS and the JavaScript for the whole site. What's relatively new in Elm, and I think was announced on their blog maybe 2 or 3 months ago, was a lot of people came back and said, well, I really like the feature set of Elm, the functional reactive programming, the nice types. But what I really want to do is have my programs live within the constraints of a normal web application where, maybe I have a whole bunch of JavaScript code, and maybe I'm building a component that's only a small piece of the page, right? Because I want to adopt this in an existing product.
All these new frameworks come out, people get excited about them, like when Rails came out, people were all over that saying, oh my God, this is the best thing ever. I want to build everything with this. And there's a lot of those that have come out in the past few years. I mean, in 2009, there was Node.js, and those communities have evolved, and they've grown so much in that time. And the functional programming group has been around for a long time, but there's a lot of that happening now, more so because of the problems that people are facing that object-oriented programming doesn't really cover. So this functional style is coming in, and people are getting excited about it again. And what do you think the reasons to use Modelviewcontroller patterns, object-oriented programming, versus functional style, unidirectional flow? How do you think you would go about figuring out, well, what projects lend themselves better to this style or that style of coding?
I think you have to consider a couple things. One is the problem you have, and one is the people who are dealing with it. And one is how you think about it. If you have a problem that, regardless of the nature of the problem, you think about in an object-oriented way, and you force yourself to write in a non-object-oriented way, then that's just not, it's not going to work. I think that there is a legitimate and clear enough case that React is a better way to make view components than Angular or other previous options, that I can't think of really any specific reason why I would tell you not to use React or some virtual DOM system if you're going to be building web UIs. Here at Pagemodo, we don't have a purely functional approach to dealing with our model level data. In fact, we're in the middle of a project that we built in Backbone and Marionette, and we're rewriting the UI in React because we're redoing the UI anyways. And the Backbone models, which are just normal object-oriented models, are just making the jump over with us. And we're writing the React view on top of them, and it's going great. So I would say, if you're in an object-oriented world now, the first thing to do is to learn more about React and think about how building your view layer with React could save on a lot of complexity about manipulating and organizing state changes. As you do that, you'll start noticing that React exerts some design pressure on what you do. It starts not liking having big global mutable objects because you end up having to coordinate with them to tell React to re-render. And it pushes you towards having a kind of single big, either immutable or kind of rarely and controllably mutated set of data that describes your UI. And at that point, you start to notice that, boy, these backbone objects really could be replaced with maps and a handful of functions that manipulate them. So I wouldn't say, if you're already in an object-oriented world, don't go big bang, right? Pick your battles, pick small things that you know are going to work well, and as you adopt them, you should start feeling, A, that it's going better, and B, that it's exerting more and more kind of back pressure further back up your stack. And then you can consider, boy, now maybe we really need to pull in reactive extensions to get some of that FRP goodness, or use one of the immutable data libraries or something like that.
I think that's good advice. Whenever you move towards the functional, people with a classical OO background that aren't ready for something new, that haven't felt the pressure of the problems with building UIs using the paradigms they're used to, feel like you're trying to shove them off a cliff.
Oh, yeah.
And they react very viscerally to that. It's actually a lot easier to get someone who's new to kind of go along with that. They don't understand that what you're doing isn't the norm, and are happy to build in whatever paradigm, which is kind of an interesting problem.
I mean, there was a time where you had jQuery, and that was the acceptable norm for doing projects. You would have just jQuery, and you were some crazy rock star or ninja, whatever you want to call them, that could do this work because not a lot of people knew it at that point, and it solved a lot of the problems people hated with the DOM manipulation and getting cross-browser compliance. So that worked for a while. And then we came across these Modelviewcontroller frameworks like Backbone, or when Angular came out, I remember I was really against it. I was like, wow, there's all these bindings in my views. It's littering the views. It's not doing separation of concerns. I pushed against it because I felt that the object way of doing it was much better and faster than doing that. And once you figure out how Angular solves a lot of the problems that jQuery didn't, then you start to think, wow, this solved something for me that I didn't realize I spent so much time developing with jQuery. I did this in 5 minutes in Angular. And then it starts to click. You start to see, wow, this tool helped me for this particular problem, while jQuery helped me for this other problem. And then React comes along and does something a little different. And so that solves something different than Angular solved. And so it's not that it's necessarily a bad tool. It's just very overwhelming for developers. Because now we have these legacy projects where you're working on a project in Angular, right? And then now the client says, well, we need to change to React, or there's another new project where you have to learn React now. And it can be overwhelming because most developers, I don't think really want to learn everything. They want to know a few things and be very good at those few things in general, not everyone. But it can be very daunting.
Well, I think there's differences and there's differences, right? There's one layer of tools, Backbone, Ember, Angular, and several others, that have differences between them and differences that people would argue about very loudly, and yet somehow exist on a kind of similar conceptual plane, right? We build objects, the objects have state changes, they somehow observe each other's state changes and update. And that whole kind of layer of alternatives, I think any of them is better than what we had before, right, with jQuery spaghetti code. And so while you can argue back and forth about Ember versus Angular, either of them ought to be way better than randomly writing event handlers.
Right.
I would argue that React is really not in the same category as Ember and Angular, that it's really a completely conceptually different way to build interfaces, and that while there's all these different alternatives about React versus other virtual DOM systems, and then once you have some virtual DOM system, how you handle the data that's going into it, that all of those really exist on a separate conceptual level than the MVC frameworks. And that in the same way that somebody who rejected Angular and kept writing jQuery 2 years ago is now behind the times, the performance benefits and the debugging benefits and the conceptual benefits of some kind of functional approach and a virtual DOM mean that 2 to 5 years from now, big ambitious things will probably all get built this way. And I think it's not really an alternative, it's really a step forward. Even if you can't use it at work today, if you're a UI engineer, you should be reading about functional reactive, and you should be reading about the virtual DOM, and you should plan to be using it as a requirement in your next job.
So we had software engineer Bill Fisher from the Flux team on a few weeks ago, and we talked about implementing virtual DOM into the browsers and what that might look like. And we talked about unidirectional flow and mostly the virtual DOM and dealing with Flux. So the browsers now deal with state pretty well, like I said. But if we look back to 2-3 years ago with UI, even 4 years ago, because you're saying 4 years, we really couldn't tell what was going to happen. That, okay, now we have Flux and we have React and we have ClojureScript and Ohm. We wouldn't have even guessed that or fathomed that. I mean, ClojureScript is 2011, right? But you have, 2013, I think, Flux, React was released. So it's fairly a new resurgence of functional programming. I don't think we would have said, wow, this is where we're going to be. Everyone just accepted the DOM as some clunky thing that didn't really work well, and it's been sort of perceived that way for a long time.
What the virtual DOM encourages, which is writing your application in such a way that it leads to, rendering this whole virtual DOM and reacting to controlled state changes in that sort of way, is, I think, going to win out over the approach that you see in, for example, Ember and Angular, in which you have two-way bindings and where there's data propagating both from the DOM to the model layer and from the model to the DOM layer automatically. The important idea that I pull out of this is unidirectional data flow, and there's a variety of ways to do that. One is by FRP, one is by something like the Flux architecture, but that, I think, is a substantially better idea than, for example, using mutation observers two-directionally, which I think, in my experience, leads to some very painful code as you get bigger projects.
So back in the jQuery days, if you wanted to have some watcher on some element, you had to do, I think there was a plugin for this that someone had created, but basically you would use JavaScript to ping the DOM and say, hey, DOM element and all of your children, I want to know if anything has changed. And that was really inefficient. So what would happen is you'd have a lot of overhead incurred on that. And the longer you did that for, the worse it got. And so when Mutation Observers started, they had similar problems. But when they were finally implemented into the browsers and tested, they actually turned out to be pretty well done. And they haven't been fully tested, obviously, because you need to have it battle hardened with large scale applications. But it's much better than it used to be, for sure.
I think a gross overgeneralization is that mutation observers make doing things the wrong way easier. They make things a lot better, but it's still down a path that you don't want to be going.
If you're talking about what I'm thinking of, the mutation observers are fired off on this asynchronous queue that's not quite the same as doing a set timeout. It fires before the set timeouts, but after the whole rest of the stack. And it definitely leads to some pain. Even aside from that issue, I would just say large-scale two-way data binding is a really painful system to work with. It's magic. It's great when you first download Angular and you get these two things to sync up. Yay, it worked. I didn't write any code. As soon as you start having lots of models, lots of different views on the same models, lots of validation rules on the models, it becomes very painful when your two-way binding works when you don't want it to, or doesn't work when you want it to, and you wish that you had just done the unidirectional data flow from the beginning, which I think results in much clearer code.
I actually like Flux. I've been playing with it and React a little bit on my own. I haven't done anything to scale, but it's pretty cool. I think that I prefer a lot of the two-way bindings so far, but I'm learning and I'm open to the different ways of doing it. It's just easy to jump on the next bandwagon too. So I'm just kind of looking forward, saying, well, in 2 years, there might be something else, and you have to keep pushing yourself to learn these things and try them out. And if they work for you, great. If they don't work for you, then at least you learn something from it.
The one thing that makes me feel good about it is, although we would have been wrong about where we were if we were trying to predict this 2 or 3 years ago because of engineering improvements, and you can't necessarily predict who's going to double down or invest in something or come up with a cool API.
Totally.
When we see this, where it's the join point between engineering improvements and something theoretical, studied in the CS literature that has now become possible and doable, it makes me feel like, aha, maybe we've really come to the right place to be exploring.
Now that we've covered a lot of the gotchas from object-oriented programming, can you tell us a little bit about the gotchas you might find in functional style?
Boy, that's tough, because unfortunately I've worked on lots of very difficult projects that went wrong or nearly went wrong with big JavaScript code bases, and haven't done anything big enough or for long enough for it to really have failed or nearly failed with these tools. Certainly with both ClojureScript and Elm, there's a big learning curve, and when something goes wrong, both of them still have slightly problematic error messages and fairly hard to debug output code in JavaScript. When something goes wrong, or when you write code that does not quite what you mean it to, figuring out what's going on can definitely take longer.
Has the community built out any tools that help offset that?
Well, both now have source map support, which is much better than we were doing previously, where you had to actually just debug the JavaScript by hand. And both actually now have time-traveling debuggers. So if you set your code up in a certain way, it's actually possible to record a set of interactions that maybe has a bug in it, say, take that recording, change some of the code to hopefully fix the bug, and then replay those interactions to see, aha, is the bug really fixed? That is a huge, huge benefit over manual testing in JavaScript, or even automated testing in JavaScript. And I think that as those tools become more complete and as they're better integrated into the frameworks, such that you don't have to sort of manually shape your code in the right way, that the frameworks push you in a direction that the time-traveling debugger can work with. I think it's not just going to be better than it is now, it'll be better than debugging tools in native JavaScript as well.
Is there a way to turn that recording into a regression test?
Yeah, I haven't specifically seen a project that does that, but it's going to happen. I mean, somebody listening to this, go do it and release it on GitHub, and I mean, you'll have 1,000 stars tomorrow.
Because that's going to be game-changing.
Yeah.
So Elm seems pretty self-contained. It seems like it has a lot of the features a framework would have. Is there frameworks that you would use on top of Elm to do a mobile or web mobile or both type of application?
Well, Elm itself, I mean, comes with the built-in sort of virtual DOM React equivalent that you can just import. I don't actually know. Presumably somebody has started building Elm libraries with different GUI widgets, but I haven't actually seen them. With ClojureScript, there are a number of different alternatives. There's Ohm. There's actually some things on top of Ohm that will set it up to work nicely so that, for example, if you're working in your editor of choice and save the file, the page will get loaded, but in the same state as it was before, just using the new code, which is amazing. So there's a lot of choices in the ClojureScript world.
So how difficult is it to deploy these languages and frameworks? Like Elm seems pretty self-contained. It doesn't seem to need another framework on top of it. But if I wanted to deploy this, how much extra stuff do I need to put on top of that?
So Elm itself, I think there are some built-in functions to do AJAX requests, but it also has a really nice foreign function interface out to JavaScript. So it depends, I guess, on what you're building. If you're starting from scratch, you might actually want to write your whole data layer and persistence layer. Maybe you're the kind of crazy person who's writing your whole app in Haskell, And so now you're going to write the model layer of your front-end code in Elm and hook it up against that web service. You could, for example, already have in Backbone or something else. And you can easily hook that up to feed those models as they change into a signal in Elm that can then, dynamically re-render your view layer.
Awesome. Is there like good resources for developers to go to get information about that sort of stuff?
Yeah, we can certainly provide some links. There are a number there's 2 blog articles, and then the whole GitHub wiki for Elm has several more walkthroughs and a couple of examples.
So I'm not sure how all of the different communities work with the compiled JavaScript, but I know CoffeeScript, for instance, will compile back to ECMAScript standards 3, so you get a lot of backwards compatibility with that, which means that you may not, in that particular version of CoffeeScript, have certain newer features in JavaScript like ECMAScript classes or imports or anything like that. Do you feel like Elm is going to include those features in future releases, or do you think they'll stick with the standard ECMAScript 5, 4, 3 type of compilation? Because their algorithm for creating this virtual DOM is going to be pretty different than a lot of the other compile to JavaScript languages.
That's an interesting question. I haven't actually heard Evan's take on that. I know in several of the compile to JS communities, there are some very specific either open questions or points of disagreement with the proposed module system. I don't know all the details of that, but that's definitely an ongoing discussion. It would be great if we could get everyone to agree on a freaking module standard, or have cross-compilation or something. It is a real pain right now. But I can't really tell you what the future will hold for that.
Okay, there's nothing on the issues on GitHub.
Not that I've seen.
Okay.
Is there anything about interoperating with JavaScript from Elm or ClojureScript that are kind of gotchas or things that you should know about? Like, for example, can you easily use D3 from Elm if you wanted to?
Yeah, and there's a couple different ways you can go about it for both. So in ClojureScript, you have access to the whole JS namespace, right? So you can always just JS/ and then access anything else on the page. And for example, with D3, there's already several ClojureScript wrappers around it with different ideas of how that API should be. With Elm, there's a defined interface between Elm and JavaScript, both to get JavaScript values in as changing Elm signals, and to take one of these Elm signals and kind of plug it back out to JavaScript and get a callback every time it changes. And then, of course, you could also write a library in Elm that ultimately just called out to D3 or something else. I haven't actually done heavy work in Elm with external libraries. In ClojureScript I have, and I've not really run into any problems.
So this is true with the most frameworks, so it's not particularly Elm specific, but I do have the question that, what if I'm using something like D3 for visualizations, and I pull this in, and Elm does this crazy optimization to make everything fast, but because I'm using D3, I'm going to be using D3's optimizations. I'm not going to gain that performance by compiling Elm into JavaScript. So my question would be, is there an idea of doing packages for Elm to lock down these things to a certain version so that you can get even more optimizations from a library like D3?
Well, I think if you're going to write a wrapper, you should probably need to bundle a specific version of D3 with it so that you're satisfying that dependency in the same way. Now there's a real problem. If you have some JavaScript and some non-JavaScript on the same page sharing dependencies, that now you have a headache. In ClojureScript, it can be especially a headache because it's optimal to send your compiled ClojureScript through the Google Clojure optimizer, for which you need to have properly annotated JavaScript. And there's a whole set of resources around how to do code optimization in ClojureScript with external libraries that is definitely a headache. there are not that many cases when writing in Elm and compiling faster than well-written, handwritten JavaScript. Certainly D3 has its own set of performance tests, and D3 is as fast on its own as it's going to get. Yeah, so what I would potentially see doing is, writing small amounts of JavaScript code that deal with the bits of rendering, perhaps, where you have maybe an interactive pipeline in the FRP style, where you're going to pass some data into Elm, have it transform through your comps, have Elm pass back to JavaScript on the far side the data describing what it wants, and then you write a small amount of kind of engine code that then does whatever you want in D3 with that output.
So is there anything that we haven't covered yet as far as ClojureScript, OM, Elm, functional, reactive, functional programming that we really should? There's definitely a need for benchmarks. I don't know if there's anything out there that you could point us to that would tell us, here's the benchmarks for ClojureScript and OM, for instance.
The most important blog post David Nolan did early on about OM, in which he rebuilds the to-do MVC example and benchmarks the OM version against Backbone and Ember and a couple others. And what you see is essentially that by achieving the minimum number of updates, the performance graph is, well, the performance numbers are much better, and also the performance graph is much clearer as to what's actually going on. So I think there's a number, as unfortunate as it is, because a to-do list is not really that complex an application, that remains the kind of standard way to test both the expressiveness and the performance of a front-end framework. And I think the Elm and OM versions stand up really well as both as short, easy to understand, and really fast.
There's also a good blog post by the GitHub Atom IO team about re-implementing Atom on top of React, which talks about a lot of the performance problems that they solved using it.
Interesting.
Can you guys post those links in the notes?
Yeah.
Anything else, Adam, that you think we should tell our listeners about these subjects?
The only thing I would say is stick with it. I had this idea that I was going to go out searching for a more comprehensible way to build web UIs 2 or 3 years ago. I tried and failed to read a number of papers on FRP. I tried and failed several times to understand the reactive extensions. I tried and failed a couple times to understand React. In fact, when they announced React at JSConf, I guess it was 2 years ago, I was among the group of people laughing and making fun of it on Twitter, not understanding what was going on. So this is not something that you should expect to do in a day. It's a real mind shift for how you think about it. You just have to think about it in terms of your professional development and intellectual curiosity. And over time you eventually make the mental shift to understanding this way of thinking of building interfaces.
Yeah, I really love it when some new framework comes out and shows us old ideas that have been made new again, and something that improves the way that we build things. And sometimes something will come along and it'll be totally new and a totally new perspective, and we'll say, wow, let's reevaluate how we build these things, hopefully to improve how we deliver to our users and our clients. So it's really amazing to me, these frameworks, and I'm really excited for Elm in particular. So if people want to find you, Adam, or contact you, how would they get in touch with you to find out more about functional programming and React, ClojureScript, OM, and Elm?
Let's see. So my website is adamsolove.com. I tweet at asolove. I'm not doing any talks upcoming. I'm going to be at the Scheme Workshop and ClojureConf in DC coming up in November. There should be lots of fun new UI stuff going on there.
So Pagemodo is hiring, and if you want to work with Adam or learn some functional programming and definitely add value to the team, definitely check out www.webs.com/careers and contact Adam.
I'm really excited to hear from people who are working with these tools or curious how they can learn the tools. If you have questions, definitely let me know. I'm happy to help.
There's going to be some great React talks at Nation.js if you're over there as well. I think Christopher Shadu, I'm probably butchering his name. He's on the React team. He's going to be talking about CSS inside of React.
Oh, I wonder if they're going to talk about their constraint-solving layout, which is a big topic at Strangeloop. It came up several times, essentially replacing CSS rules with a more declarative way of saying where different components should be on the page using a constraint solver. There have been whispers that the Facebook team has been working on it, and it would be awesome if that were what he was presenting.
Thanks again.
Thank you. Yeah, it's been a lot of fun. Thank you, guys.
This episode comes to you, at least in part, through the support and sound equipment generously supplied by 3 Pillar Global. 3 Pillar is a software product development company in Fairfax, Virginia, and 3 Pillar is a leader in creating purposeful and innovative product experiences. 3 Pillar was recently named to the Washington Post Top Workplaces list for 2014. So if you want to follow 3 Pillar on the Twitters, it's at 3 Pillar Global. And to find out more and see current job openings, please visit 3pillarglobal.com. That's 3, the number, pillarglobal.com. Thank you.